Hi everyone, it's Coach Fred here, and today I'm going to be going over the graph of a quadratic function in vertex form. So we know that a quadratic's graph is going to be in the form of a parabola, so maybe something like this. But quadratics can come in many different forms. We can look at them in vertex form, standard form, intercept form, and so we want to make sure we understand what all the constants mean, what they show us. So vertex form is going to be of the form y equals a x minus h plus k. So in class so far, you guys have already really actually figured out that the vertex works out to be hk. So if I give you a function in this form with a binomial square, a square of a binomial, you know your vertex here would be then 1, 8. All right. Now, the axis of symmetry of the graph is a vertical line that goes straight down the vertex. All right, so if it's the axis of symmetry and it goes straight down the vertex, that means that point, 1, 8 right there, the x coordinate is 1, so my axis of symmetry would be the vertical line x equals 1. Now, if you think about that, if I wrote it just looking at the general function, that would mean x equals h. All right, so then how do we find the y-intercept? Y-intercept isn't something you can see looking at it in vertex form. So remember, to find the y-intercept, we set we set x equal to 0 and solve for y. Set x equal to 0 and solve for y. All right, so in this case, we're going to set x equal to 0. So we have y equals 3 times negative 1 squared plus 8. So we have y equals 3 plus 8. So y equals 11. So my y-intercept is the point 0, 11. Okay, I'm going to actually plot those. So I've got 0, 11. So way down here. So 1, 2, I think it's one more off. So it's like right here, 0. Oh, that's negative 11. Way up here. 0, 11. And I've got a vertex of 1, 8. 1, 2, 3, 4, 5, 6, 7, 8. Oh gosh, this terrible graph. And we've got this mirror, this line of symmetry going right down the vertex. So we can use the y-intercept to find a symmetry point. So it has to be the same distance away and have the same y-coordinate. So it would be right there, and its point would be 2, 11. I'm sorry, this graph didn't work out so pretty. So my symmetry point would be then 2, 11. So to find your symmetry point, you just want to reflect either the y-intercept or any point over the axis of symmetry. Okay. X-intercepts. Well, I think we can see this opens up and it's opening like this. So therefore, we have to really be careful and see there's no x-intercepts. So in this case, we want to think, though, there could be zeros or roots. So how would we find those? So we're going to go through the process of finding them so you know what to do if there are x-intercepts. So to find the x-intercepts, we set y equal to 0 and solve for x. Okay, so in this case, it would be 0 equals, let's look at that equation again, 3 times x minus 1 squared plus 8. Okay, so now this is in the form that we'd really want to use the square root method here. So I'm going to subtract 8. Okay, so we get negative 8 equals 3 x minus 1 squared. We're going to divide by 3. Okay, and so we get negative 8/3. So I now have, I'll come over here, x minus 1 squared equals negative 8/3. I'm going to take the square root of both sides. So x minus 1 equals plus or minus, let's see, that's going to give me I root 8 over root 3. Yuck, I have to rationalize the denominator and simplify. So I'm going to multiply by root 3 over root 3, which is going to give me plus or minus I root 24 over 3. Root 24 can be simplified into square root of 4 times square root of 6. So that would be plus or minus 2I root 6 over 3. And I still have that x minus 1 equals. Now I move the 1 to the other side, and I get 1 plus or minus 2I root 6 over 3. Okay, so that's a root. That's a solution to the equation. But remember, we talked about the graph. The graph, if it has an imaginary root, it won't cross the x-axis. And so that's why our graph didn't cross the x-axis. All right, domain and range. The domain should be easy for us here. We know that it's all real numbers, negative infinity to infinity. Okay, my range, you specifically have to look at the y-coordinate of the vertex, right? We've learned this. Okay, so the y-coordinate of the vertex we said here was 1, 8. So 8, and it's going up. So it would be hard bracket 8 to infinity. Okay. Our intervals of increase or decrease, as a reminder, this is when you use that slope number line, and we look specifically at the turning points of graphs. And so if I think about that, the turning point here is at the x of 1. On the left side of 1, it's a negative slope. On the right side of 1, it's a positive slope. So we know that our intervals of increase or decrease, let's start with decrease, would be from negative infinity to 1. So that's going to be our decreasing. And our increasing would be from 1 to infinity. Remember, we don't ever have to worry about brackets because a turning point is neither increasing or decreasing. All right, min or max value. So this is opening up. So it's going to have a minimum value right there. And so our minimum value would be 8, the y-coordinate. All right, so what I suggest you do is now you go through that whole process on the next page. So pick one, or do both if you'd like. The answers are posted online for you to check. And make sure that I gave you some space to find your x-intercepts, but if there are no x-intercepts, make sure you find your roots. Now, hopefully you're seeing that if it is in vertex form, the square root method is going to be the best way to find those roots. All right, guys, hopefully that was a helpful video. Have a great day.